This is question 39 of Civil Engineering paper GATE 2013. A 2 km long pipe of 0.2 meter diameter connects two reservoirs. The difference between water levels in the reservoir is 8 meter. The Darcy-Weisbach friction factor of the pipe is 0.04. Accounting for frictional entry and exit losses, the velocity in the pipe is. So in this question, it is given that a 2 km long pipe of diameter 0.2 meter is connecting two reservoirs, and the difference between the water level in these two reservoirs is 8 meter. The Darcy-Weisbach friction factor of the pipe is given as 0.04. Now considering the losses due to frictional entry and exit, we need to find the velocity of the flow in the pipe. So this question is from the topic of pipe flow. You may study about the different types of losses in detail by watching lecture 22, losses in pipe fitting, fluid mechanics by Professor Subhashish Zatta, IIT Guwahati. So as we know, when the water flow in the pipe, then there are many losses, and that losses are generally categorized between two types: major loss and minor loss. In the major loss, we consider the frictional loss, and in the minor loss, we consider the entry loss, exit loss, losses due to pipe bending and others. So here in this question, we need to consider only three losses, which are frictional, entry and exit. So here the head difference between two reservoirs is 8 meter, and this loss is due to, we need to consider frictional loss, loss due to frictional, and loss due to entry, and loss due to exit. So here we know the total head loss is 8 meter, and the formula to find the frictional loss is FLV square by 2GD, where F is the friction, Darcy-Weisbach friction factor, L is the length of the pipe, V is the velocity of the flow in the pipe, Z is the gravity acceleration, and D is the diameter of pipe. And head loss or losses due to entry is can be calculated by the formula 0.5 V square by 2G, and the losses due to exit is V square by 2G. So just here just substitute this term with the value. So friction factor is given as 0.04. Length of the pipe is 2 kilometers. So 2 kilometer means 2000 meter, and velocity we need to find V square by 2 into G. So G is 9.81, and diameter of the pipe is given as 0.2 meter, plus 0.5 V square, 0.5 V square by 2G. So G is 9.81 plus V square by 2G. So V square by 2 into 9.81. When we solve this equation, we will get V, the velocity of the pipe, as 0.63 meter per second. So we got here the velocity of in the pipe is 0.63 meter per second. So 0.63 is given in option A. So option A is the correct answer for this question. Thank you.